Hi, my name is Callie Burke. I am a trajectory analyst for Launch Services Program, and I'm also the lead in my innovation time for the Space Apps Challenge at Kennedy Space Center. So we have four challenges we brought as the 35 for Space Apps, and so one of them is Survivor Mars Latitude. And so I have Jim here with me. He's the challenge creator, and he is going to talk to you today about the challenge and the work he does. And just so everyone knows, for Kennedy, for our four challenges, which this is one of them, there's the global judging that will be based on, each location is going to be nominating one to go to global judging. But for the Kennedy challenges, we're actually going to hold our own separate judging. We're going to have it where we have a panel of experts who are involved in the work that your challenge had to do with. And every project that creates the 1-minute video, just the same as the requirements are for global judging, you create that video and work on a Kennedy challenge, even if you weren't nominated for global judging, we'll do our Kennedy challenge or Kennedy judging for each of those, and we'll pick a top project for each of our four challenges, and there will be a prize associated with that. So we look forward to seeing your videos. And so during this hangout, if you have any questions, we'd love to hear them and have Jim answer them for you. You can use, there's a question and answer Q&A that you can use within this Google Hangout, and so that's the best way, because we'll see those as we're looking on the screen. I'll be monitoring the Twitter hashtag Mars Latitude. I'll also be looking for Mars Latitude's Hackpad, and so those are the ways to ask this question. So and with that, we'll have Jim go ahead and introduce himself.
I think I'm unmuted now. Okay. Thanks for having me, Callie. I work in the Granular Mechanics and Regolith Operations Lab at Kennedy Space Center's SwampWorks facility. And there, what we do is we do a lot of work for in-situ resource utilization projects. We have the capability of testing excavation and rovers and various ISRU equipment in a very large regolith testbed. It holds 120 tons of planetary regolith simulant that allows us to freely excavate the regolith and convey it from place to place inside this test bin, and in order to evaluate these types of technologies. We're interested in Mars as well as the Moon and asteroids. We're interested in utilizing the regolith found at those destinations. For Mars, we're interested in lava tubes and the regolith, Martian regolith, as a resource in which we can that we can utilize. We can the Martian lava tubes themselves will provide provide protection from space radiation for astronauts that travel to Mars. The regolith itself can contain water, which is a resource that astronauts that might be living in habitats that are enclosed by these lava tubes will need. They can extract oxygen from the regolith, from the minerals that contain oxides. So there are various chemical processes in which you can utilize to extract important resources from what is normally thought of as just dirt. Oxygen and water being the primary ones. You can also, if you heat the regolith to very high temperatures, you can decompose the elements that make up the regolith. You can extract metals, for example, and you could use the metals maybe to make spare parts in a 3D manufacturing process. So inside a lava tube, you can envision astronauts living in some kind of habitat. Maybe not the lava tube itself. Maybe there's some inflatable structure that is going to fill up the lava tube. And you'll need construction materials to support the habitat that's located in these lava tubes. So we're interested in seeing what kinds of scenarios, concepts that the people who are working on challenges under this challenge can come up with. We're looking for some creative solutions.
Great, thanks, Jim. So we actually have some participants that are working on the challenge right now who joined our Google Hangout. So, and actually one thing, if any of the viewers are interested in joining us, email us at SpaceAppsKSC@gmail, and we'll try and send you the link. So we do have a limit, but I think right now we should be good. You will need a Google account to do so. So now we'll go to, and you guys, I can't unmute you, so when I put the video on you, you have to mute yourself or unmute yourself to be able to ask the question. And afterwards, then mute yourself and Jim will answer it. So.
Yeah, if anybody has any questions, just feel free to ask.
So Chris, you guys are still muted right now.
Hey guys.
Hi.
So we are actually building kind of like an educational game. So we've gone for kind of like a very traditional 2D platform style game where the user kind of navigates a player through what you might call a treacherous lava tube. And essentially, we'd like the user to encounter certain features of lava tubes. And at the moment, we're thinking the user will kind of collect gems or something similar, which will bring up interstitial informational pages that perhaps give them a little bit more information about what type of features or characteristics they might find inside a lava tube, how they might be formed, and ultimately in the context of Mars, where their strategic value is in terms of sustaining a community on the planet and gathering resources and that kind of thing. So with that in mind, I guess we would be interested in any information on key characteristics of lava tubes on Mars, particularly, and kind of given that frame, anything else that you think might be worth delivering as an interstitial informational page as part of the experience.
Keeping in mind that the game is targeted to very young teenagers to get them interested in STEM subjects for future studies and to raise awareness for sustainability and resource management.
Very good. Well, one thing you can think about is that this is sort of like mining in space. So the lava tubes give you access into the, below the surface of Mars. It's kind of like if you wanted to, where you do mining, the kinds of activities there might be similar. It's just that the lava tubes give you access below the ground already. So as far as how you can, how they might learn how to search for materials, you might look at some of the websites that mining industries have developed. I recently came across a Canadian government's website that was pretty instructive, because if you think about it, the northern part of Canada is an extreme environment where it's very cold, and it would be somewhat similar to Mars, except that we have an atmosphere that you can breathe on Earth, and you don't have that on Mars. But a lot of the activities would be somewhat similar in both locations. Inside a lava tube, I'm not sure on Mars. We've only observed the presence of lava tubes from orbiting spacecraft that image the surface. And the way you discover that there are lava tubes on Mars is that you see these openings on the surface, and we haven't been able to probe inside them yet, so we don't really know what they look like inside.
Okay, thank you very much. I do have a follow-on question, if that's okay.
Sure.
Actually, let me right before you do your follow-on, I did want to say, if you want to know more about lava tubes here on Earth, we did a hangout yesterday with the High Seas group, and they actually explored lava tubes. And so if you go and watch that YouTube video, they talk about their experiences in them. And then the High Seas group and some other ones talk about the Earth ones. And you do know that they have water that comes in some of our lava tubes. And we had a geologist who, she just spoke very briefly in the previous Google Hangout about how they're formed. But the High Seas one that we had yesterday afternoon, that one has a lot more about lava tubes, because they actually have more experience with lava tubes than Jim does.
And that's in Hawaii, right, Callie?
Yes, the High Seas group, that's a Hawaiian one. That's an analog one.
Yeah.
Very cool, thank you. We'll check that out.
Yeah, that'd be great.
What was your question?
Yes, I just wanted to ask, you mentioned one of the virtues of lava tubes being that they give access to kind of like the core of the planet, or you know, certainly deeper than you'd be able to go from the surface. Do you have any? I mean, I know you obviously haven't. We haven't been able to explore lava tubes on Mars, but do you have any idea of what kind of resources or minerals or ores might be present down there?
Yeah, if you visit Wikipedia, and I believe it's let me check here. I think I might have it. There's a wiki page on, here we go, Martian soil. So if you search for capital M, Martian, and then underscore, and then soil with a lowercase s, that'll take you to a Wikipedia page that will tell you some of the constituents that are in Martian regolith. One of the things you might also consider is that the lava that flowed through this tube in the previous hangout that Callie monitored, the geologist from JPL said that the way these form is that they cool from the outside in. And so what that means is that the outside is probably going to be fairly hard, maybe brittle, because the minerals are, you know, when they harden, they may be brittle. So somehow you're going to have to penetrate the lava tube in order to get to the free regolith outside of the lava tube.
Okay, thank you very much.
Yeah.
And as a note from the High Seas one yesterday, they talked about the outside. Yeah, the top of it was much harder, but when the High Seas guys, when they were inside, there were places where it was very fragile. There might be places, locations within, where you can get the material a lot easier just because of the way the cooling works. It's more accessible inside the lava tube as opposed to on top of it. At least that's what I recall them saying during the Google Hangout.
Yeah, it's possible that they can cave in and you can get some free regolith on the inside of the lava tube. It's not clear, you know, they can meander, so they may go parallel to the surface and then go dip down. So it's not, I'm not sure on Mars, because the gravity is 1/3, I think it's 1/3 Earth's gravity. The flow of lava is going to behave a little different than it does on Earth in, say, Hawaii.
The research we've done indicates that the lava tubes are considerably wider,
yeah,
and larger. So,
yeah. So gravity probably allows them to expand. The lower gravity allows them to expand in dimensions. Well, that's
And we
good.
have
Sounds
that.
like you've done a lot of research.
Mhm.
Yeah.
Okay. Let's see, if you guys don't have any additional questions, I'm not seeing any on the rest of the internet. But let's see.
Let me think.
So a big thing that also that Jim you were interested in was massless exploration and using in situ resource utilization, ISRU. Do you want to talk a little bit about the research that you guys are doing regarding those two elements?
Yeah, so what we do is we work with chemists that are interested in extracting, for example, oxygen out of the regolith. And the way they do that is they cause a chemical reaction to occur when they heat the regolith to about 1,000 degrees C. In the presence of a hydrogen atmosphere, the hydrogen will react with certain minerals in the regolith, producing water. So you can actually, even if water is not present in the regolith, you can produce water through a chemical reaction with hydrogen at a high enough temperature. And so you can make water from the water. You can perform electrolysis on the water, extract the oxygen and the hydrogen, and reuse the hydrogen. So this is a clever method of reusing hydrogen in this process of producing oxygen. Once you have the oxygen, you know, astronauts could use it for breathing, but you could also use it as a propellant. So that's how they could get around on Mars, using an oxygen-based um, engine. So
That is awesome.
Yeah.
That's
And
amazing.
Also, yeah, and also the CO2 atmosphere on Mars. You know, the Martian atmospheric pressure is about 1/100th the atmospheric pressure on Earth, and it's about 95% CO2. And the chemists have also come up with a method of extracting the oxygen from CO2. So that's another way of producing oxygen, which is a valuable resource. So you got to think about these, you know, these in your educational game. One aspect could be to have the students think about um, how the astronauts could become self-sufficient by living off the land, literally. Right? They can make their own water, they can make their own oxygen, um, and not have to rely on those resources being brought from Earth. So that's if you look on the description of this Space Apps Challenge, there's a reference to a concept called evolvable, or I'm sorry, it's, help me, Cal.
Massless, I think.
Massless exploration, that's right.
Yes.
So that means you don't have to bring the mass with you. You can make these materials that consumables at the destination you're going to.
Yeah, and I think one item we had also when we wrote when you wrote the description was the idea of possibly doing 3D printing. Even though we're still just very much experimenting with 3D printing in space, in the future that might be something they can do. So not only are you getting out these resources, but then you might be able to make them into exactly that tool you need using stuff that's local.
That's right. So if you heat the regolith, like I said before, in the presence of oxygen, you can make water. But what do you do with that hot regolith? Well, you might be able to form structures with it. So that's a way of manufacturing using the heated regolith. That's normally you would think of that as a waste byproduct, but you could actually use it to make say landing pad structures, or structures to support the habitats inside the lava tubes. The other thing is, if you heat the regolith to maybe 1,500 degrees C, the individual metals, the elements themselves will start to come out of the the regolith, and so you kind of start to vaporize the metals inside the regolith. So you can think of aluminum. You might be able to extract aluminum. There are 3D printers that are metal based now, so so that could be a feedstock for a 3D printer. So you could. The other advantage of the lava tubes, besides exploration, you know, for science, there's science benefits by exploring lava tubes, but you could also use them as facilities to manufacture products like I was mentioning, you know, 3D printed materials, structures, oxygen. All those could be part of an underground community.
Yeah, we're still a ways off from exploring Mars, so we still have lots of technology that might develop between then and now. Go even further beyond what we've already got.
Yeah, so we're hoping to travel to Mars in the 2030s when you guys are still young, and I hope that I'll still be around to see that.
Where do we sign up?
Well, just stay tuned.
Oh, it's amazing work that you guys are doing. Incredible. Yeah. I had no idea about reusing the regolith for some of that, or for some of those applications. Incredible.
I mean, even the creation of water and of oxygen.
Yeah. So there's we have a couple of I think we have a Facebook page. It's SwampWorks, KSC SwampWorks, that you can find. And that'll probably have links to other, what we call ISRU, in situ resource utilization, the acronym is ISRU, related pages.
There's also, they have a Twitter account if you guys are active on that, and I think I've actually found that their Facebook and Twitter pages are the best way to know what's going on with SwampWorks. So it's something, you know. There's things like skunkworks and other things. That's kind of Kennedy's, one of our big innovation technology ones. And if you see we did a hangout yesterday that was actually at SwampWorks. You can hear. It's not the best audio, unfortunately. We didn't realize the setup for the lab wasn't what we had, but you can actually see. We do a tour of the lab towards the end of the video, and we show different things going on in SwampWorks. And so, yeah, it's a fun place for even somebody who works at Kennedy to go visit and see what robots they've got going on. And they also, if you want to talk a little bit, Jim, about the robotic mining competition that we have coming up in May. I can't remember if we're in our 4th or 5th year for that.
Yeah, it's a competition for universities, and there's also an international competition. So it doesn't have to be a U.S. university. But the one in the U.S. is held at Kennedy Space Center at the Visitor Center, and so there's, I think, approximately 50 universities in the U.S. that will be competing, and the competition involves students developing excavation machines that can excavate the regolith, and they're mobile, and the winner is the one who can excavate the most regolith in a given amount of time. And in this year's competition, the goal is to find as much ice as possible in the regolith. And the ice is actually, since we're in Florida, and it's hard to find ice at our temperatures these days in Florida. So the ice is actually represented as rocks. So we use white rocks as ice in the regolith, and so the competitors are going to try to gather as much ice as possible. And there's going to be there's an international competition, so universities in England and all the countries are going to compete also in the international competition, and I think they meet up at a later date in Hawaii. So that's a good goal to shoot for.
Yeah, it's definitely, I've been able to go out a couple times. It's really fun to do, and you realize that off-world exploration of surfaces beyond Earth it is not the same thing. There's lots of lessons learned from what's going on Earth, but it's a different environment. So, well, do you guys have any more questions before we wrap up the Hangout?
I'm all good for the moment.
Likewise.
Thank you.
Thank you both very much.
Yes, it was very interesting.
And where are you located? In England?
In
Yes.
London. Mm-hmm.
In London. Okay, very good. Well, good luck in the challenge.
Thank you.
Well, we definitely appreciate it. England's got great participation. So, all right. Well, thank you guys so much. We really look forward to it, and so we really will appreciate getting to see your video of what you guys put together, which hopefully you'll be putting together next week. But thanks so much, Jim, also for joining us, and good luck to everybody who's working on the challenges. We really are looking forward to it. So have a good one.
Thanks, Kelly.
Thank you very much, guys.
Thank you.
Goodbye.
Bye.
Bye.